Hello everyone, and welcome to the solution for the e-commerce on-site question 1. So, as always, you can check out the solution notebook, which has the problem statement and then the entire solution as well as an explanation and some code. So this is what we're going to be working through here and explaining how it works. So let's just go ahead and reiterate what the problem statement was. You were given a list of historical stock prices for a single day of Amazon stock. The index of the list represents the timestamp, and then your task was to write a function that will return the maximum profit possible from the purchase and sale of a single share of Amazon stock on that day. So, for example, given this list of stock prices, your function is going to return 7, the maximum possible profit, which was buying at 3 and selling at 10. Alright, so let's go ahead and discuss a few things before we start coding this out. Again, you should have tried to solve this with paper and pencil first. In this solution explanation, I'm actually going to code stuff out so the syntax is clear of what we're doing. But again, you should have done this with paper and pencil first, or on a whiteboard, since it's going to be the most common way to explain these problems in a real interview scenario. Okay, so let's go ahead and think of a few things before we start coding. One thing to think of right off the bat is that you can't just find the maximum price and the lowest price and then subtract the two, because the max could come before that minimum, and then you would have an incorrect solution. So brute force method is just to try every possible pair of price combinations, but that's going to be order n to the power of 2, which is pretty bad. And since this is an interview setting, you should already be aware that there's probably a smarter solution than just brute forcing it. However, if you ever get stuck on a problem, definitely at least do the brute force solution first, and then see if you can get a better solution. In this case, what we're going to do is use a greedy algorithm approach. And again, there's a Wikipedia link here in the solution notebook for you to check out the full definition of a greedy algorithm. But basically what's going to happen is we're going to iterate through that list of stock prices while keeping track of our maximum profit. And that means for every price, we're going to keep track of the lowest price so far and then check if we can get a better profit than our current max. So let's go ahead and implement this. So I'm going to make a function called profit, and it's going to take in a list stock prices. And then we're going to start the minimum price marker at the first price. So in this case, we're going to create a variable called min stock price. And it's going to be equal to the first element, that first price. So we have a minimum price marker, and it starts at the first price. And then we start off with a profit of 0. Max profit, what we want to return at the end, equals 0. And then what we're going to do is say for price in stock prices, we're going to do a couple things. First, we're going to check to set the lowest stock price so far. So I'm going to say minimum stock price equals, and I'm going to compare using the min function, which returns the minimum given 2 arguments. So I'm going to say min stock price and price. So it's going to check the current price as we go through that list of stock prices and check it against the minimum stock price we've seen so far, and then set the minimum stock price to whichever one of these is less. Then we're going to check the current price against our minimum for a profit comparison against the max profit. So I'm going to make another variable, call it comparison profit, and I'm going to set it equal to the current price minus the min stock price we've seen so far. So here we have the current price we're looking at minus the minimum stock price we've seen so far. And that's going to be a profit, right? Because you have a price minus the smallest one you've seen earlier as far as stock price. This should get you the profit that you need to compare at. So let's go ahead and check that profit against our max profit so far. So I'm going to say max profit equals max between our current max profit and then our comparison profit that we're comparing to. And after that, you just need to return max profit. Okay, so let's go ahead and see if this works. Profit. Let's go ahead and just pass in a list. So we'll do, let's say, 23, 12, 310. So max profit should be 7. So buy at 3, sell at 10. All right, great, this is working. So we're currently able to find the max profit in one pass, which means order n time, and in constant space, order 1, since we're not making an entirely new list. So we're still not thinking of any edge cases. So for example, there could be situations where the stock price always goes down, or if there's less than 2 stock prices in the list. Before we take care of those edge cases though, and write an improved function, let's go ahead and make sure we understand our original function. So, we take in the list stock prices. Set a variable for the minimum stock price we've seen so far. We'll start that off as that first element. Then, we want to output our max profit, which we start off at 0. Then, we go along for each price in that stock list, take the minimum stock price we've seen so far by comparing the minimum stock price we start out with the current price we're looking at, and take the minimum of those. So now we have min stock price, and that's going to be the smallest price we've seen so far. Then we want to take a comparison profit, some sort of temporary variable to compare our max profit to, which is going to be the current price minus the minimum stock price that we've seen so far. Then, for the max profit, we just compare max profit to that comparison profit and take whichever one was greater. Once you go through all the stocks, you would have found the max profit possible, and then you can return that. Okay, so now we have 2 edge cases we want to consider. One is if there's less than 2 stock prices in that list, and the other is if the stock price always goes down. So, if we jump over to the solution notebook, we should see a function called profit2. And instead of coding this out, what I'm just going to do is walk through the improvements here, since the function itself is really similar, just taking care of these 2 situations, these edge cases. So if there's less than 2 stock prices in the list, that's really easy to check. We just say here the length function, len. So we check length right off the bat. We say if length of stock prices is less than 2, we raise some sort of error. Need at least 2 stock prices for that day. The first one, the stock price always goes down, is a little trickier, but we can take care of that by returning a negative profit if the price decreases all day. That way we can know at least how much we lost. So how do we actually do this? Again, we start with a minimum price marker, set it as the first price. And here's where it's a little different. We start off with initial max profit, which is just the second element minus the first element. So index 1 minus index 0, that first possible profit. Then, for each price in stock prices, skipping that very first element, index 0, since we've already taken it into account in the max profit, we're going to do some reordering here in order to track a negative profit if it shows up. We take our comparison profit first, which we can do since we've already set max profit equal to the second minus the first element. Then we compare our max profit, and then we check the lowest stock price. And after you do those comparisons in that order, you return max profit. So, if you pass in a list of a single element, you'll have this error or this exception raised, need at least 2 stock prices. If the stock prices always continue downwards, you can take care of that as well by returning best case situation where, in this case, it would be buying at 22, selling at 21 for the minimum loss, which is -1. All right, so make sure to keep edge cases in mind, especially if you solve the original question fairly quickly. And make sure you review this question. It's a pretty common one, so it's important to know about greedy algorithm approaches and how you can use it to solve this problem. All right, go ahead and review the solution. Hopefully you did well on that problem, and I'll see you at the next solution lecture. Thanks, everyone.